Now, in the last video, we talked about linear transformations, and we talked about what a linear transformation is, how they're defined, and the rules behind linearity. And in today's video, I wanted to talk about linear transformations and their matrix representations. So every linear transformation can be represented by a matrix. So if we have a linear transformation called T, and it's mapping the vector space V to the vector space V prime, we'll have a rule that assigns that transformation. And what we can do is we can find the matrix representation of that transformation. So here I have this linear transformation that's defined by T of xyz equals x plus y and y minus z. So for this transformation, I'm taking a vector that has three different components. So it's in the vector space of R3. And I'm sending it to a vector that only has two components. So the answer is going to be in the vector space R2. So this linear transformation T is taking vectors in R3 and is sending them to be vectors in R2. So let's see if we can find the matrix representation of this transformation. So the first thing that I'm going to do is I'm going to try the unit vectors. So we'll start off with the first unit vector, 1, 0, 0, and we'll see what we get once we plug all the numbers into the formula. So x plus y, that's going to be 1 plus 0. And y minus z is going to be 0 minus 0. So I'm going to end up with the vector 1, 0. So next I'm going to try the unit vector 0, 1, 0. So if I put that into the formula, I'm going to have x plus y, that's going to be 0 plus 1. And for the next component, I'm going to have y minus z, and that's going to be 1 minus 0. So if we do the math on that, I get 1 comma 1. Now the last unit vector in 3 space is going to be 0, 0, 1. So if I put those into the formula, I'm going to get 0 plus 0, and then I'm going to get 0 minus 1. So that's going to give us 0, negative 1. So now I've got these three vectors that come from the transformation. I've got 1, 0, I've got 1, 1, and I've got 0, negative 1. So those are going to end up becoming the columns of my matrix. So over here, we're going to write the matrix representation of the transformation. So that's going to be T bar. And what I'm going to do is I'm going to set those vectors that I got as columns. So the first column of my matrix is going to be 1, 0. And the second column of my matrix is going to be 1, 1. And the last third column of my matrix is going to be 0, negative 1. So what we're doing here is we're writing the vectors as columns of the matrix. And that is how you find the matrix representation of a linear transformation.